So rates and ratios are comparisons of two quantities, and these comparisons are either of times or divide types. So we want to times and divide to be able to go from one ratio or rate to another ratio of rate. So we also have things called unit rates when we compare the quantity to another quantity of one. So it says here, write the unit rate and use a unit rate to solve the problem. So Brian scored 38 goals in 25 games. Okay, so I'm going to write this as a unit rate. So first of all, I'm going to write it as 38 goals to 25 games. And I'm going to do this as a unit rate of one game. So to do this, to find a unit rate, I divide. Okay, it's just like finding a multiplier. In fact, the unit rate becomes our multiplier or divisor in our problem. So I'm going to take 38 goals divided by 25 games, and I end up with 1.52, and the rate is goals per one game. Here we write it as goals per game. So that's the unit rate, and then we can use this unit rate to solve this problem. So it says, how many games does it take for him to score 50 goals? Now, when we're doing rate problems, it's going to be times or divide. So it's sometimes hard to determine if I should be timesing or dividing. So in this case here, what we can do is this, and this is using a multiplying strategy. So I have 50 goals, and I'm going to multiply by this rate. But I want to make sure I have the rate in the right direction. So it could be, in this case here, I've got goals, and I want to end up with the number of games. Okay, so the games has to be the result of this calculation, has to be the answer. For this to happen, I need to have the 1.52 goals in the denominator, because the times on top of goals will cancel the units of divide on bottom goals. And then on the top I have one game. And notice that I have the correct units. I have the number of games. I'm just going to highlight that because that's important. I'm left with the number of games where the goals are the units of goals, and again notice I'm doing unit analysis here. The units of goals cancels out. So then I do 50 divided by 1.52, and that will give me the answer of 32.89 games. Okay, so this is one way to set it up so that I can see whether I should be dividing by the 1.52 or multiplying by the 1.52. Okay, and we can do this in all sorts of different ways. And again, if we get stuck on this and we're not sure about this strategy, we can always use our equivalent fraction strategy. So we have 38 goals in 25 games, and we want to know how many goals, we want to know 50 goals in some number of games. Our multiplier here is 1.52, so we times by that. So we can see that we dividing by the 1.52 shows up over here. Divide by 1.52 because we're going in the opposite direction as our multiplier. Okay, when we find our unit rate, that is our multiplier from bottom to top. So in this case, we want to go from top to bottom, so we want to divide. So here we have Solly. He buys 8 bagels for $3. So I'm going to write this as a proportion, and I'm going to do this for bagels per dollar. Okay, instead of, we could also do it dollars per bagel. Okay, so actually, in fact, I'm going to do dollars per bagel. So let's do, and again, it doesn't really matter, but I'm going to do $3 for 8 bagels. And when I do the division, when I do 3 divided by 8, that gives me my unit rate of 37.5 cents per bagel, or $0.375 per bagel. So that's my unit rate. I want to know how many bagels I can get for $8. So I'm going to start with $8, and I'm going to multiply, and I want to be left with bagels. So I have to check my units and the direction of my units. So here the $0.375 has to go on the bottom to cancel with the dollars on top. So $0.375, and that's one bagel. So in this case, again, I'm going to end up dividing. And if I set it up differently, I would have ended up multiplying. But in this case, I'm going to divide. So 8 divided by 0.375 gives me 21.3 repeating bagels. And again, we can confirm this by setting it up as a ratio problem. $3 to 8 bagels is going to be $8 for some unknown number of bagels. My multiplier is 0.375 going from bottom to top, so I'm going to use that as a divisor from going from top to bottom. So another place that we see ratios is in slope. The slope is a ratio of the change in y, the vertical change along a line, so how far I move up from this point to this point I move up, and compared to the change in the run, or the change in the horizontal from this point to this point as I go up. So first of all, I want to find out how much this changed. So this is a relationship comparing costs to number of minutes used. So maybe this is a cell phone or something like that. So we have $40. To find out the rise, we're going to go $40 and we're going to go up to 70. To find the distance, I'm going to subtract. So I end up with, I go up $30. And to find the horizontal change, again I subtract. So I ended up at 1,000 minutes. And I started at 500 minutes, so I have an increase of 500 minutes. Okay, so whenever I want to find distance along a line, I subtract. So the change in y to the change in x ratio, so the change in y over the change in x, that's going to be equal to, so I've calculated my change in y to be $30, and the change in x is going to be 500 minutes. Okay, so this is my slope of this line. That's my rate. Okay, so that is the change in y over the change in x represents the rate in the graph. And in fact, I can simplify this and find a unit rate. And my unit rate, I would find that by just dividing those two numbers. So I do $30 divided by 500 minutes, and that gives me $0.06 per minute. For every minute, it costs me 6 cents. And so that's what the rate or the slope in this picture is showing me.